Hey guys, I wanted to make a quick video on 5.1, 5.2, at least as quick as possible. So this is all about laws of exponents. Unfortunately, there's not really just one that I can throw in there and make work. So I kind of got to go over all of the laws of exponents, which I think will be a good review anyway. So let me pull up the laws of exponents as they're written in the book. There are a few rules. There's the product rule, the zero exponent rule, the negative exponent rule, the quotient rule, power of a product rule, and the power of a quotient rule. And so basically, what the rules say is if I am multiplying two things with the same base, I can add their exponents. So a to the m times a to the n becomes a to the m plus n. And maybe just to show you an example of that, maybe I say I have something like x cubed times x to the 8th. I'm multiplying two things with the same base, so I add their exponents, I get x to the 11th. The zero exponent rule just says that any number that's not 0 raised to the 0th power equals 1. So if I had, x to the 0, x could be anything. Assuming that x is not 0, then it gives me 1. But if I had 5 to the 0th power, that is also 1. 100 to the 0th power is 1. That's all that the zero exponent rule is saying. The negative exponent rule is one of the ones that a lot of people get confused, and that's where I kind of want to spend the most time on with this video, is talking about what to do with negative exponents and the quotient rule. Because the negative exponent rule says that anytime you have a negative exponent, you have to get rid of it first by moving the entire expression either up or down depending on where the negative exponent is. So what I mean is this. If I had 5 to the negative 2 power, that becomes 1 over 5 squared. The 5 is on top, so it moves to the bottom, and then becomes a positive exponent. So then I can say it's 1 over 25. But if I had like 1 over, or let's do 3 over 5 to the negative 2, where now the negative 2 is on bottom. This negative 2 only belongs to the 5. The 3 stays where it is, but the 5 comes up and joins it and becomes 5 to the positive 2. So the point is that the negative exponent changes the location of whoever it's on. If I have a negative exponent on the 5 on bottom, it moves to the top. If I have a negative exponent on top, it moves to the bottom. I don't want you to think the negative exponents are like flipping or anything. That's all that they do. So this becomes 3 times 25, which is 75. All right, so keep in mind, that's how I get rid of negative exponents. I can't really do anything with them except get rid of them. Okay, and then I'll start a new page because I want to show you the other laws. The quotient rule says that if you're dividing two things with the same base, you subtract them. So multiplying two things with the same base, you add their exponents. When you're dividing two things with the same base, you subtract their exponents. And the order does matter. It's always the top exponent minus the bottom exponent. And so you can kind of see why that's important, because now, like if I had x to the 5th over x cubed, one way to think about this is write it out x times x times x 5 times over x times x times x 3 times, and see that the x's cancel out to just leave me with x squared. But the truth is, the better way to do it is to say, okay, well, the quotient rule tells me that x to the 5th over x squared, I'm dividing two things with the same base, so I subtract their exponents, top minus bottom, and that gives me, I changed the problem. X to the 5th over x cubed becomes x to the 5th minus 3, which is x squared. So it's just a faster way to simplify these problems, and you can see why I needed the negative exponent rule then, because now if I said like x to the, I don't know, let's just do 8 over x to the 15th, the rule says to subtract their exponents, top minus bottom. So x to the 8th minus 15 gives me x to the negative 7th. And so sometimes when you're subtracting, you might end up with negative exponents. That gives you then 1 over x to the 7th. You could think about it. If I subtracted them, I would get 7, but that 7 should belong on bottom because the bigger exponent's down there. I think it's a bad habit that people try to get into, though, by doing it all in their head. I think the best way to do it is do the subtraction, top minus bottom, and then determine where it goes. And since it has a negative exponent, it moves to the bottom and becomes a positive 7. That's the best way to simplify with negative exponents. So let me just finish up these other three rules. Sorry. The power rule says that if you have a power to a power, you multiply them. So if I had, x to the 5th to the 10th power, I don't want to write out x to the 5th times x to the 5th times x to the 5th times x to the 5th 10 times. If I did do that, I would add their exponents all together. I would get x to the 50th anyway. So the shortcut is I can just multiply powers to powers and be done. Let's see, what else do we got? We have the power of a product rule. So if I have a power outside of more things happening on the inside, that power belongs to everybody. So if it's a quotient or if it's a product, it doesn't matter. The power of a product or the power of a quotient, that exponent belongs to everybody on the inside. So if I had x over y squared, I could think of that as x being squared and y being squared. Or if I had x times y being cubed, then I could just think of that as x being cubed and then y being cubed. That exponent belongs to each of the terms on the inside, no matter how many terms there are. All right, so that's a lot of rules. You should go back and maybe watch them, spend some time on whichever ones you think you're having the most trouble with. But in my experience, it's usually the negative exponent rule and the quotient rule. So I want to focus a little bit on those and just show you some different types. Let's say that I was starting off with an expression like x cubed y to the 4th over x y to the 10th. This one doesn't have an exponent on it, so it's assumed to be a 1. Anytime the exponent's not there, it's assumed to be 1. But if I just go in pieces, x cubed over x, you subtract them, 3 minus 1 gives me x squared. Y to the 4th over y to the 10th, you subtract them, top minus bottom, and that gives me y to the negative 6th. Right? 4 minus 10 gives me negative 6. But I don't want to, if I'm asked to simplify this, then I don't want to leave my answer with negative exponents. I can actually break that down a little bit further because a negative exponent tells me to move y to the 6th on bottom, and that's my final answer. So when you're asked to simplify, you should make sure you have one of each variable and no negative exponents, also no powers to powers. That's how it works. But just take them one at a time. Simplify the x's first, then the y's. If there's more variables, do that. Let's say maybe we have an entire expression inside some parentheses, like 2x over x to the 6th, and then let's raise it to a power, say to the 5th. I could do a few things. I could distribute that 5 through to everybody because that's what the power rule says, right? Or the product and quotient to a power says that this 5 belongs to everybody. But that's going to give me a lot of terms with variables on them. So I like to simplify the inside first every time, if I can. Meaning the 2, that doesn't have anybody to simplify with. But the x over x to the 6th, I could simplify that. Subtracting the top exponent minus the bottom exponent gives me x to the negative 5th. That's just the inside. That's just me doing the x's. Now, that 5 does belong to everybody. 2 to the 5th is 2 to the 5th. You can simplify it. And then x to the negative 5th gets raised to the 5th as well. This 5 belongs to the 2 and to the x to the negative 5th. So that gives me 32. 2 to the 5th is 2 times 2 times 2 times 2, 5 times. And then x to the negative 5 to the 5th power. I can multiply those powers. It gives me x to the negative 25. After each step, you should kind of just pause for a second and say, am I done? Am I done? Am I done? Here, there doesn't look like there's much more I can do, but I do see I have a negative exponent. that negative exponent only belongs to the x. The 32 doesn't have an exponent on it, or a negative exponent on it. So the 32 stays put where it is. The x to the 25th goes down there. It would be a different story if I had 32x to the 25th, the negative 25th, because then the negative belongs to everybody. But this is not what I have. I have 32x to the negative 25th. If there's no parentheses around everything, then the negative 25th only belongs to the x. So maybe one more time, maybe I have 3x to the 4th over x to the 8th, and then I square all of that. Again, the 3 I can't do anything with, but the exponents on the inside, I have x to the 4th over x to the 8th. I could subtract those. 4 minus 8 gives me negative 4. Right? It's x to the 4 minus 8th power, top minus bottom, so that's why it becomes a negative 4. But then when you square it, that 3 belongs to everybody, so it's 3 squared, and x to the negative 4th squared, which gives me 9 times x to the negative 8th. So if I stopped here and asked myself if I was done, I'm done simplifying the inside. I mean, I guess I can get rid of the negative exponent. But really, this 2 belongs to everybody. So I decide to distribute it through next, and that gives me 9 times x to the negative 8th. And now I see the only thing left to do is make the exponent positive. So it becomes 9 over x to the 8th. Notice that's not the only way to do this. So let me just do the same problem and start out with 3x to the 4th over x to the 8th. I'm saying I would simplify the inside first, but if you didn't and you distributed that 3 through to everybody, you get 3 squared x to the 4th squared over x to the 8th squared, right? That 2 belongs to everybody, so I could distribute that through first, and that would give me 9 x to the 8th over x to the 16th. And then I could subtract their exponents and get 9x to the negative 8th, so that it becomes the same thing over here. You could do this in any order. That's the beauty of laws of exponents. It doesn't matter the order. What does matter is that you're following the laws. So I always do the problems the same way. That way they don't seem like different problems. I'll simplify the inside, then I'll distribute the exponent through, and then I'll worry about who goes where. Do they have negative exponents? If they do, I'll move them to the bottom. So let me show you one more type. All right, let's say I have negative 7 y to the 6th x a to the negative 2 all to the negative 3rd power. Now, this looks a lot longer, but just think about the laws, and I think you'll be okay. Ask yourself where you would start. I would start simplifying the inside. If I look at it, though, there's none of the same variable. There's nothing really for me to do to simplify. If I look on the outside, though, there's a negative exponent. And so I'm not really a fan of distributing the negative exponent through to everybody. What I would prefer to do is just move everything to the bottom because it's all raised to the negative 3rd power. So that becomes negative 7 y to the 6th x a to the negative 2 all to the positive 3rd power. Because I had a negative exponent, everything on the inside stays what it was, but this negative 3 becomes a positive 3. Nothing else changed. It's on bottom, though. So now this 3 belongs to everybody. That becomes 1 over negative 7 cubed y to the 6th cubed x cubed a to the negative 2 cubed. Just do them in pieces. What do I have left to do? Well, I should simplify 7 to the 3rd power, 7 times 7 times 7. Well, negative 7 times negative 7 times negative 7 is still negative 343. Y to the 6th cubed, that becomes y to the 18th. They have a power to a power, so you can multiply them. X cubed is just x cubed, and then a to the negative 2 cubed is a to the negative 6. I could have distributed the negative exponent through, but like I said, negative exponents confuse a lot of people, so I like to get rid of it first and then simplify. Now if I look at this, everything's pretty much simplified except for this negative 6 here, the problem that's in the exponent. So that means that negative 6 only belongs to the a. It moves up top. It becomes a to the positive 6 over negative 343 y to the 18th x cubed. And if you want to, you can write the negative out in front. That's what we usually do because we don't like the bottom to be negative. The whole fraction should be negative. It's negative a to the 6th over 343 y to the 18th x cubed. Notice the 343 didn't move. It doesn't have a negative exponent. It was a negative number. And a positive divided by a negative is a negative fraction. That's the only reason the negative's changing over here. It's not really moving at all. So try 2 of them and put them on Math Excel. I think they'll be good practice working with negative exponents. They're not necessarily the longest or the hardest type, but I think they're good practice in where people have the most confusion. All right, so try it out. Let me know what you think.